All right, so as I was saying in the last one, we're looking for like and unlike terms. We've determined what terms are in an expression. Now we have to determine what like and unlike terms are. So the variable parts of two terms determine if it is going to be a like term, which is the same, or an unlike term, which is different. Okay, so that's the key, the variable part. So with like terms, two terms are like terms if they have identical variable parts. Now that means the two terms must contain the same variable raised to the same exponential powers. And if they don't, well, then we've got unlike terms. And two terms are unlike if the variable parts are different in any way. Okay, whether it's a squared versus a cubed or a versus a b. If there's anything different, then they're not like. So what we want to do is we want to look at these four here as examples and determine if they're like or if they're unlike. Okay. Well, again, we're looking only at the variable part. That's all we care about. So here we have xy. Here we have xy. Is there anything different? No, there's not. So these are like terms. What about this one? We have an x and an x squared. Well, here that's an x squared. This is an x. So those are going to be unlike terms. Well, here we have an x and a z. Well, those are really unlike terms. At least these both had x's, just one was to a different power. So again, those are unlike. What about x squared and x squared? Well, those look good. Those are both the same. So we'll say those are like, okay? And then what we're going to do now is after we determine if they're like or unlike, we are going to start combining like terms, okay? And so combining like terms, we're going to use the distributive property. And so we're going to look at these and say, okay, we've got 4x plus 8x. Are they like or not? Well, we have x and x, so they're like terms. And so then what we do is we take that like term part and we pull it out here. And then we look at what's left. Well, we have 4 plus 8. Okay, and so we put that in parentheses in front. And then we take 4 plus 8. Well, that gives us 12x. Okay. Now again, this is the long way around, and that's what we're going to learn first, and then we'll move into a shortcut. All right, so we have a negative 8xy squared plus 2xy squared. Are those the same? Yes, they are. So what we can do is we can say, well, that's xy squared, and then in front of that, we're going to take a negative 8 plus 2, just like we did up here. So now a negative 8 plus 2, well, that's 8 minus 2 is 6. The sign of the larger is negative. So that's a negative 6xy squared. And that would be our solution. Okay. Now what about here? We have an xz and an xy. Are those like terms? Those aren't like terms. So what can we do with this? Nothing. So that's already our answer. So that would be what we could write it down again if that's what we had to do. But there's nothing we can do with this one because those are not like terms. All right, so here we have an x squared. Well, that's a y squared, so that's not like. There's another y squared, that's not like. But hey, those two are like. So I'm going to double underline those. And I'm looking for an x squared also. Well, there's one there. Okay, so we've got two different sets of like terms here. We've got these two, and we've got these two. And so what we're going to do is we're going to say, well, let's take this 3 and then minus 8 and put that by x squared, and then say plus, and here we have a negative 4, and then we have plus 2, and that's with a y squared. Well, a negative 8 plus 3 is going to give us a negative 5x squared. Negative 4 plus 2 is going to give us minus 2y squared. Okay. And so that would be our answer. Now we could also say a negative 5x squared plus a negative 2y squared if we wanted to, but we could go ahead and leave it this way because the key thing is when we get done, we want this to be as short as possible. Well, when we have a plus a negative, that's one extra thing that this one doesn't have. And this one represents exactly the same thing as this. And so this is going to be our ideal solution to this problem. Okay, again, this one's a solution to it, but this is the ideal solution that you want to use. All right, so if you notice, basically we're just adding the coefficients together on the like terms. So when we use that distributive property. So when we have these common variables, like terms, it's just quicker to add the coefficients. And so what we're going to do is we're just going to make sure we have like terms, and then we're just going to add 7 and -2. Well, 7 minus 2 is 5, and our like term was x squared. Okay, what about here? Well, here we've got a z squared and then an x squared. Those aren't like, and then a z squared. Okay, well, those two are the same. So what we're going to do is we're going to combine those two, and we have a 7 plus 4 is 11 z squared. And then we still have a minus 2x squared. We can't add that in, so it stays as part of the problem. Okay. Now what about this one? We have three terms. We have an xy term, an xy term, and an xy term. So guess what? We can add the coefficients here. 7 plus 2 minus 8. Well, 7 plus 2 is 9. 9 minus 8 is 1. And so we just get 1 times xy, or just xy. Now what about our last one? We have an x squared, x squared, x squared, x squared. So those are all like terms. So what we can do is we can take 8 minus 7. Now this one you might have to do in pieces. So we can do 8 minus 7, and that's going to give us a 1. And then 1 plus 2, well, that's 3. And then 3 minus 3, well, that's 0. So we get 0 x squared. Well, what's 0 times x squared? Well, that's just 0. Okay, so sometimes you're going to get an answer where there's no variable or anything left, you just get a 0. Okay, so that's a key thing to think about. And sometimes when you get done, you end up with negatives. Sometimes you have positives. It all varies depending on what your coefficients are on those like terms. All right, so we'll pause there and we'll come back in a second.